Hello everyone. Uh, I am going to explain about how to convert infix expression to the postfix expression, and I will also explain why we need to convert infix to the postfix expression, and later on by using the hashtag I will convert infix to postfix, and then I will implement it in Java language. Here, first question is what is infix expression? As you can see the definition, the expression of form A operator B when an operator is in between every pair of the operator. Here you can see A multiplication B. It means here operator is just between both the operator, and so this is the infix expression. But in case of the postfix expression, operator lies just after the all operand. जैसे like you can see here a b फिर multiplication. It means uh, all operators should lie at the end of the expression, and this is the postfix expression. Now here the question will arise that why postfix representation of the expression we need. Actually if we see uh, the uh, perspective from the perspective of a machine that calculate the infix expression, then we will understand better. Here uh, it is a infix expression. If we want to calculate this infix expression, then first of all we would check the operator with higher precedence. As we know, the multiplication and the division have the higher precedence and compare than uh, plus and minus. So first we will check operator with higher precedence, and here multiplication is present, which is the higher precedence compare than plus. Then we will just calculate b into c first, and then we will uh, check from starting to end position in the expression that operator just less than the multiplication precedence, and then we will calculate that. It means here number several number of the scanning takes place from the starting to end position of the expression. But if we convert it into the postfix expression, then a machine can just solve it by the one scan. How? After the, let's see, after the conversion of infix to the postfix expression, this is the postfix expression, and this is if a machine want to calculate this postfix expression, just machine start to scan from left side, and if any operand encounter, then just leave it, and as control will reach at this position. It means operator first operator which encountered, here is the multiplication, here the multiplication is the first operator, then machine uh, just take previous two operand and this operator, and calculate the value of this expression. Now what is the value of the here you can see uh, if b multiplication bc multiplication, this is the postfix expression of the sub expression, then machine will calculate just like this. And let's result is z. Then after the calculation, this infix expression, this will look like this: a z plus d plus. And now again machine uh, will proceed from their previous position, and the next expression is the plus. Then again process is same, previous two operand and this operator uh, will combine to solve like this: a z plus and a plus z. Let's answer is x. Then the final expression like uh, x d plus, and again uh, it will solved x plus d, and let's answer is the m. And then the final answer will be the, then you can see here in only one scan machine can solve the postfix expression. That's why we need to convert the infix to the postfix expression. Now here we can see the a small infix expression, and after the conversion here is a postfix expression. This for this small infix expression. Actually machine use the stack, and we know a stack is a property of LIFO. What is the full form of the LIFO? LIFO, it means the last in first out. It means element which pushed into the last will pop out in the at the first. Here this is the postfix expression. Actually for the solving of the postfix expression machine use the stack. Here in the at the initial position stack is empty, and the first in the first step just push the operand. Actually one by one machine will push all the operand in the stack. You can see first push 2, then push 3, and then push 4. After the push 4 in the stack, element will look like this: 4 3 2. Actually here you can see 4 is the last element which is being pushed in the stack, and here is the at the top position. And now after the pushing 2 3 4 in the stack, here is the first operator multiplication will encounter. And as I said earlier, whenever the any operator will encounter, then just pop out previous machine just pop out the previous two operator and solve it. Here is the two previous operator 4 3. You can see here the explanation: pop 4 and 3 and perform 4 into 3 is called the 12, and then 12 push into the stack back. And after the push, stack will look like this: 12 2. And again after the multiplication there is a plus operator, and whenever operator occur, then previous two operator will combined with that and just solve. Then machine will pop previous two operator like pop 12 and 2 perform 12 plus 2 14 and push 14 into the stack. Now the result of the above expression is the 14. You can see how machine just calculate the postfix expression and effectively by using the stack. That's why we need to convert the infix to the postfix expression. And here is the precedence order. We already know about this. Bracket have the higher precedence, and then the exponent and the multiplication, then division, and then the addition and the subtraction. But assume this is the expression minus and the plus. As you know, minus and plus is the same precedence. Then which operator will calculate first? And there is a rule: if two operator with same precedence are present, then go from left to right. Then here is the left, at the left position there is a minus. Then first we will calculate this operator and then plus, and finally we get the postfix expression. Now as we seen how the machine just solve the postfix expression by using the stack, and this is the process to solve the postfix expression by the machine. But here is an important question, is that how machine just convert the infix expression to the postfix expression. It means this process. Then so we are going to first know how the machine convert the infix to the postfix expression, and then machine solve that postfix expression. So the question is conversion of infix to postfix expression using the stack rules. Actually machine use the stack to convert the infix expression into the postfix expression, and there is a rules. As you can see, there is the rules, but if you trying to read these rules, then it is difficult to understand. So first I am going to explain an example. Like this is the little bit complex infix expression, and I am going to just convert it to the postfix expression using the stack, and this process basically is used by the machine. So I am going to explain it now. This is the infix expression, as you can see, and actually machine use the stack for the LIFO because of the LIFO last in first out properties. Actually there is a stack, and this stack, just remember that this stack will contain and only the operator which is in the infix expression, and process is that machine just start to scan from the left position, and first when any operand encounter, then just concatenate with the output expression, as like you can see, and when any operator like plus encounter, then just push into the stack. As you can see, plus is in the stack, and then at the next position This is the operand, and just operand is the concatenate with the output. Now next uh, next element is the operator. Then process is the same, just push into the stack, and there is a top position. This position is the top position, as I mentioned. uh, then after the pushing the operator, uh, this is the stack. And now next, actually this expression is same as this. Now you can see also here. And after the a plus b multiplication, bracket encountered, and again bracket, just we will assume like the operator, and just push into the stack and ab, and the next is the c. Again c is an operand, then a b c, and the stack will same as previous. Now the next is the uh, n- now the next is the exponent operator, and just push into the stack. Now here is the d, and we will concatenate with output expression. Now minus operator. Here see, uh, if machine will go to push into the stack, then there is a rule that uh, any operator any operator which is already in the stack have the less and equal precedence. Then less and equal precedence, then uh, just 1 second. Now here we need to just uh, push the minus operator into the stack, but we will check any operator which is already in the stack have the higher and the equal precedence will first pop out, and then uh, push this operator. As you can see, here is the exponent operator have the higher precedence compared than the minus. So at the next position, first pop out this expression, this operator, and then push the minus, because of this operator yeah, exponent have the higher precedence compared than present scanned operator. So just pop out, and after the pop, just concatenate with the resultant expression. It means the output expression. Now after the minus, there is a e operand, and e operand you can you know that the operand will just simply concatenate with the output expression. Now the next operator is the just closing bracket, and here is also a rule: if any closing bracket is encountered, then first previous all the operator which is after the opening bracket will pop out one by one, and just uh, concatenate with the output expression, like minus. Here's the minus, and at this position there is a closing bracket encountered. Then first machine behave like this as uh, pop the minus and concatenate with the output expression, as we can see. And is the remaining and uh, this opening bracket will disappear. Now the final at this position final expression is plus and the multiplication. Now that the next, similarly as the previous step, there is the exponent, and this exponent also will push, and after this again opening bracket. The opening bracket, whenever encountered, just push it, into the stack, and after the push, there is a f, and this f, and this f just uh, concatenate with the output expression, and after the output concatenation, so the plus, just push it back, again g just concatenate multiplication, and then the multiplication, just push it into the uh, just push it into the stack, and then h, just concatenate with the output expression. Now the again closing bracket. After the closing bracket, as we know, the all the operator will pop out one by one, and push, concatenate with the output expression. Now the remaining expression, this, and remaining expression after this, and after the there is a minus operator, and minus operator, and you can see all the operator which are present in the stack have the higher precedence compared than the higher and the equal precedence compared than the scanned operator. So here machine also pop out all the expression one by one and concatenate with the output expression. As you can see here, first exponent will pop out, and then multiplication, and this multiplication is here, and after the plus pop out and the concatenate with the output expression. Now now push the minus, and after the minus, just I encountered, which is an operand, and just we know, just concatenate with the output expression. Now after at the next position, there is a stack having the one operator, just pop out, and the help concatenate with the output expression. Now it is the final postfix expression of given infix expression. This infix expression, this infix expression. Now during this example, I have already told all the rules which I had used in this, and these rules are present at the previous page, as you can see, and this is the rules. You can just read it and understand. First, the scan the infix expression from the left to right, as I said. If the scanned character is an operand, output it, and a scanned character is an operand, just concatenate with the output. As you can see, if any operand encounter, then just machine will concatenate with the output. So if the scanned character is an operator, then just output it, and else if the precedence of the scanned operator, if here you can see if any operand occur, just concatenate with the output if any, and that character is operator, then just follow these rules. AB, if the precedence of the scanned operator is greater than the precedence of the operator in the stack, if the stack is empty, if the stack contains closing opening bracket, just push it. You can see greater than the precedence of the operator in the stack, just push it, else pop all the operators from the stack which are greater than and equal to in the precedence than that of the scanned operator. After doing that, push the scanned operator to the stack. If we encounter parentheses while happening, then stop there and push the scanned operator into the stack. What is this rule? As you can see here, here, mm, as I said earlier, this is the exponent operator having the higher precedence than the minus. Then first we will pop out and concatenate with the output expression, then just push it into the stack scanned character. That's what this rule. Now if the scanned character is an opening bracket, then push it to the stack. As I said, any opening character, any opening bracket, just push it, don't compare with any precedence. If the scanned character is in the closing bracket, then pop the stack and output it, and until opening bracket is encountered, and the discard both the parentheses. As I said also, any closing bracket encountered, then just pop all the operator from the stack till the opening bracket, and then push the scanned operator. Repeat steps 2 to 6 until the unfixed expression is scanned. Print the output as the output which we will concatenate it. Pop and output from the stack until it is not empty. Then this is the rule. You can understand. Now I am going to implement this process. Yeah, it means if any user pass any infix expression as the input, then our code will just execute it and give to the user as postfix expression in output. Let's see. Now I am using the IntelliJ IDE for the implementation of the infix to the postfix. Now as you know, there is a main method in the Java, so I am going to create the main method, and expression, there's an expression as the in the form of a string, which is infix expression. As you can see, I am taking the same example which I have explained in the slides. Now a plus b c d minus e, and then exponent, then opening bracket f plus g into h minus I. These are infix expression. Just convert it into the postfix expression and output it. Now I'll create a function fun inf to post, and just I will pass. Now here I am creating a function which will just return the string, which is our output. Fun to post string and the expression. Now in the example there was output, so as the output I am going to take result. This will be the output, and at the initial position it is the empty string. Now as we know, in this process a stack data structure is used. So I am creating a stack in which just character will be pushed, and new stack. Now I am going to just scan all the character from the string one by one and process it. Now int I equals to the 0 and the I is less than the expression dot the length and the I plus plus. Now just take the first character from the string, char at I. Now check this expression is an operator or operand. For the check in the Java there is a method is letter or digit. If it is an operand, then just simply we will concatenate with the previous result. And if here if this condition will false, then of course it will be the operator. Then operator, first check the that operator is any type of the bracket or not. For that ch just equal to the an opening bracket and if any opening bracket will encounter, then just push it to the stack and if any closing bracket encountered, then we know any closing bracket, then we will pop all the expression till the opening bracket and concatenate with the output. For that for that, uh, stack, first of all we check stack is empty or not, because maybe the stack is empty, and if stack is should be not empty for this execution, that's why I just write the negation. Now stack dot the at the top position, we will check this opening bracket. This is the while loop till this opening bracket not occurred, not encountered, sorry. And now we will concatenate with the just a result by popping all the operator one by one. And after the popping, we'll just pop again. It is for popping the opening bracket, opening for popping the this, because after the popping all the operator, we have to just pop into the pop the opening bracket. Now at this position, if any, you can see here, if any operand will occur, then this will execute. Any opening bracket, closing bracket, then it will happen. And else, it means here 100% scan character will be the operator. Now as we know, we will pop all the operator from the stack till the scanned operator having the higher precedence. So first of all, after the execution this, we have to create a function which will return the precedence of the scanned character. So first of all, we will create the static int precedence and char ch. For this I will use the switch case, the switch, and the first case, as we know, this is, and the second case, sorry, second case, then I will return the 1. Why? Because here as we know, minus and plus the same precedence level, so that's why I will return 1 for the both. Now next case is multiplication. And I will just return the 2. This is the exponent. Now the return 3 because higher precedence. And if any other character is not lies in this, then just return the -1, because having the least, it will having the least precedence. Now just move to the next this else block. And this is else blocks, while first just check the stack is empty or not, and just precedence of the scanned character equal to the precedence of the stack dot the peak, which at the top position in the stack. Now result, and just concatenate with the previous obtained expression, stack dot the pop. Now after the popping all the operator having the higher precedence, just push it to the scanned character. Now after this process, if there is any operator is present in the stack, then just pop all the operator one by one and concatenate with the output expression. For that I am using this result result plus stack dot the pop, and after this process we will return the output, which is our required answer. Let's see. What is the output? Output should be correct, and you can say this is the our postfix expression. And postfix you can compare uh, as as we solve the manually. Just 1 minute. Where is the output expression? No, you can now you can compare both are the same expression as this and our output. uh, so thank you.